So let's look at our first example with induction. Use mathematical induction to prove that 1 plus 2 plus n equals n plus 1 over 2 for every integer n greater than or equal to 1. So when you're doing mathematical induction, your first step is always going to be the basis step. You have to show it's true, that this formula is true for our initial value of n, which is 1. So your basis step here, what you need to do is you need to show the statement or formula is true for n equals 1. So let's look. If n is 1, what is the left-hand side? 1. The right-hand side is 1 times 1 plus 1 over 2. And that equation is true. It says 1 equals 1. So we've established that the formula is true for n equals 1, which was our basis step. So now let's do the inductive step, the second part of our induction, our mathematical induction. Inductive step. So remember that you start by assuming the statement is true for n equals k. And that needs to at least be 1. So when we're proving this, it might help if you think in terms of that, like starting point and conclusion that we talk about a lot with proofs. Our starting point, we're going to assume that the formula is true when I plug in k. And then, what conclusion are you trying to reach? Conclusion to be shown. You need to show that the formula is true for k plus 1. So 1 plus 2 plus k plus 1 equals k plus 1, k plus 1 plus 1, or k plus 2 over 2. And so now we're going to write the whole proof for this part. Starting with our starting point, assume 1 plus 2 plus k equals k plus 1 over 2. And now we're going to work with our formula here. Well, remember that the term that comes right before this last one is k, so I can write this as 1 plus 2 plus k plus 1. And then for this part right here, I can use my formula that I've already assumed is true right here. I can plug that in. This is k plus 1 over 2 plus k plus 1. And let's go ahead and get a common denominator here, because we want to combine these fractions. We want to combine these terms together. My common denominator would be 2. So I can now combine them together. And if I factor out a k plus 1 out of the top, I'll be left with k plus 2 over 2. And if you look at what conclusion needed to be shown, that's exactly what I needed to get. I needed to get k plus 1 times k plus 2 over 2. And that completes my proof right there for the inductive step. And so we've established the formula is true for every value of k